Okay, let's talk about very quickly some quick announcement. Just let me add a new page over here. Okay, let's say, let me write it down here. Lab number 7 was posted yesterday. This lab over here is not going to be graded. Okay, not to be graded, and also no submission required. Lab number 7 is really about Java API, specifically about ArrayList and Hashtable. I will test you on ArrayList and Hashtable in the exam. So for your best interest, complete them and compare your solution with the sample solution. I gave you both. Okay? And for this week, for Monday, Tuesday, and Wednesday, you don't have to attend your lab session. Okay? No attendance of your lab session. For those of you who need to take a makeup test for test number 2 or test number 3, you have to show up today, 6 p.m. Okay, that's your last chance. For Wednesday this week, so Wednesday will be our final class. Just make sure you show up. I'll talk about some tips for the exam. Okay, just make sure you come on Wednesday. All right. So today the plan will be I'll try to finish almost everything that's important today. Maybe some light stuff in the beginning of Wednesday to finish off, but mostly today. I want to finish about how you can manipulate ArrayList and also Hashtable. Basically for ArrayList and Hashtable, the most important stuff is to have a mental picture about how things work. For ArrayList, it works just like an array. You just have to be a little bit more flexible about removing stuff and growing the array. And for the hash table, I'll give you some very clear mental picture so you can follow through the code. Guys? All right? Okay, so now let's talk about this quickly. In the exam, what you will be given will be either ArrayList or hash table. I'll make sure you don't have to memorize any of the headers for the methods. You will always be given something like this. It's so-called API for the class, okay, API. Okay, so now let me just recap very quickly. API simply means if you want to program using ArrayList, what kind of methods can you actually make use of, okay? So now typically you have, for example, mutator, you can see the return type is simply void. In this case, you can add something. We'll show you how to do this method specifically. You can add something and then you can read through the description about how to use that particular method. On the other hand, you can also use accessor methods, in which case you can see returning integer, returning boolean, and returning some element type, and etc. Okay? So when you are given a particular API, you're going to read through the API and see how to use it. There's some technique you want to pick up. That's the main learning outcome for this for the last lecture and this lecture. Let's now just go through the common methods for ArrayList. Let's continue from what we left off from last Wednesday quickly. Okay, let me just tell you the lines we have completed and I'll continue on Eclipse. For lab number 7, it's actually quite an interesting case study for a mixed use of the ArrayList and also hash table. So do try to attempt that yourself and then compare your solution with my sample solution. So let's have a look at the first line quickly. So what we have done, first of all, we can declare a variable called list over here, and then you're trying to try to create an empty list. I'll write this line specifically bigger. So if I have ArrayList, so this is the type of the Java class. And then you have some special syntax to follow. Again, in the exam, if you got any written question, you are not required to write syntax for the Java collection. It's a little bit too new to you, okay? But you're expected to read the code like this, okay? ArrayList, and then we got angle brackets over here. What you put over here is to say every element of the ArrayList, which is pretty much like an array. What should be their type? In this case, I simply say it's string. Okay, I'll just put string inside. And then declare the name of the variable like that. How do you create a new object? You simply say it's assigned to the address of some new objects over here. And then you simply repeat exactly what you have over here on the left-hand side. Okay, ArrayList. Just for your knowledge, Java compiler somehow is smart enough to figure out exactly what the type should be on the right-hand side. So when you get more experience enough, you can simply leave this part just empty. Okay, you don't have to mention string. You can mention that, it doesn't hurt, but you don't have to. After that, we simply put the version of the constructor taking nothing. So this is going to create an empty array list. So this is the only version of the constructor you're supposed to know for the exam. Okay? So that simply creates an empty array list, like an empty array. Okay, that's the first line. And then after we have created this particular object of type ArrayList, we're going to call the various methods to manipulate it. Let's see the methods we're going to call. What we showed last time. We show the size, we show contains, we show indexOf. So now let me just give you a little recap very quickly. How can you figure out exactly the kind of value that's going to be returned by each method call? You have to look back to the API declaration. I'll give you several examples over here. Let's say for this one here, when I say list.size over here, I know that list was declared to be of type ArrayList. So now the size must come from its API. So if I go back to the API for the ArrayList, I can look for size, which is over here. Size is an accessor, which returns an integer. It tells me exactly the number of elements in this list, right? That's how you figure out, that's kind of the process for you to figure out any method call from the API. Similarly, if you look at contains over here, again, the context object is also, again, list. And list was declared to be array list. So if you go back to look for contains, contains is exactly over here. Contains tells you returns true if the list contains this particular elements. For example, in the beginning, we simply have an empty list. Let me draw that. So list after the first line over here is simply just going to point to an empty list. I'll just put it like that. Just means no elements have been stored so far. So size is simply just 0. And A does not exist in this particular list. So that's why it should be just false. It does not contain. The next one, what about indexOf? The indexOf is very similar to what we did in the tutorial video. It also were tested somehow in the lab test. So now, indexOf simply tells me if I'm given a particular element over here, if it exists in the array list, tell me where it is in terms of the index. Indices in the array list start also with 0, just like the array. And then if the element does not exist, return -1, the same conversion as we did in the tutorial. In this case, A does not exist in this particular empty list, so that's why it should just be -1. Okay, that's where we have gone through last Wednesday. Any question about this before I move on? Okay, basically that's just one more method, two more methods to show how we do insertion, how we do deletion from the list, and then we just manipulate the list a little bit more. And again, the best advice I can give, every time you're trying to trace the code for OOP, the best way to do it is by drawing some picture on your sketch paper. You may have to do that a lot during the exam, okay? That's how you trace the program. So now let's do the next one. If I switch back to the Eclipse over here, okay? So now if you simply, okay, you can see that. If I just execute the program over here, you can see that initial size of the list is simply 0. 0 is the return value from size. And also contains list that contains A, it does not contain anything. So simply contain anything would just be false. And also the index of some non-existing element should just be -1. Okay? So far so good. Let's try to do a little bit more. Let's say I try to add something into the list. So there are two ways for me to add something into the list. Either I can say add it to the end of the list, or I can say add an element to a particular position of the list. Let's try the first version, which is easier to understand. So now I can simply just go and, okay, let me just try to type the next line. So now list will still be the context objects. As soon as you say dot, in Eclipse, it's going to show you a drop-down menu of all the methods you can call. In this case, we're going to say add. Okay, even for add, again, we talk about the idea about method overloading. Just review what it is. Method overloading simply means with the same name of the method, you may have different versions of the method with different parameter types. So now we're going to call the version that's very easy to see. Just one single parameter. I just want to add one single element into the list called A to the end. So this is the first version of add. It's pretty much like an add course, add students, or add order. You just add something to the end of the array. Okay? Let's do another one. I can say list.add, and then I would say, okay, just make sure you call the right version. Just one single parameter to be expected. So I will just put over here. Okay, I will also pass A and B. So what does that mean? So after these two lines, let's just try to see this. So what we have done was these two lines, list.add A, list.add B. Okay, very easy to visualize. After this particular line, we're going to add A into the list. After the second line, you just add another one. One thing to notice, the way we visualize array is a little bit different. It's a little inflexible. The way we visualize the array, we simply create the array of some fixed size, where every element there is simply null. The way we do the array list is completely flexible. Initially, the array is simply just empty, storing nothing. And then we can grow that one by one. We can also shrink it one by one. Okay? That's kind of the flexibility you want to get used to. Okay, after these two, now we can simply try the various accessor method we tried before. Let's just have a quick preview. So now if I say list.contains A is indeed over there. Okay, so that will just be true. If I try list.contains B, for example, it will also be true. We can also try list.contains C. C is not there because only A, B are in the list, so that should be false. Let's try that in Eclipse right away. If I go back to Eclipse over here, what I can do is I can say system.out.println. Okay, let me just do a little bit more one line to show you. List.contains. Okay, I can say A, and also list.contains. Okay, remember this is the logical operator we have, right? It's conjunction. We want to make sure both are going to return true. And also we're going to say system.out.println list.contains C. Okay, we know that this expression over here is going to be true, and this expression here is also going to be true. True and true will give us true. And then contains C should give us false, right? Let's verify that quickly. If you look at that, it's going to be true here and then false here, right? Okay, easy to follow. What about indexOf? If you look at indexOf, let's again go back to the pad over here. If you look at indexOf, list.indexOf A does exist in the list. So where is that? Well, it should be index 0, right? If you look at that, indices 0 and 1. Indices for the array list, just like an array, they start with 0. So that should be 0. What about indexOf B? It should be 1. What about indexOf C? C does not exist. Should be -1. What about indexOf D? Also -1. Anything that does not exist in the list has the index -1. Let's now put this into Eclipse quickly. Okay, so now what I can say is I can say system.out.println list.indexOf. Let me just do A to show you. Okay, if I say A does exist, and then if I try that, it's going to tell me the index will just be 0, position 0. Okay, let me just try one more. Of course, if you try B, it's going to be 1. But what if I try C? C does not exist. In which case, I would see -1. Okay, so that's about how to work the indexOf. Let's now get to something a little bit more complicated, a little bit more. We want to have a second version of addition, insertion. Let me show you how it looks like first. So the line I would like to execute now is this line here. I'm going to highlight in pink. Okay, I want you to compare these two lines. First of all, to convince yourself, this line over here and this line over here. These two lines, they are both calling the add method. However, the first one is only taking 1 argument. The second one is taking 1 and 2 arguments. So now the first argument there is going to be an integer. Okay, let's have a quick look. So the version we're looking at is basically this version here, at. It's going to take some integer index and also some elements over here. Let's read it through. Insert the specified element at the specified position in this list, which means if I have over here 1 and also C, what does that mean? I want to insert C somewhere in the list, but where? Index 1. But the problem is, there is already an element at index 1, which is B. But how should we deal with this? You didn't know how to deal with it. We didn't deal with that exactly in your tutorial in the labs previously. But this can be done in Java library. This can also be done in the array. But that's a bit too advanced, so I didn't really show you. So now, how does it work? So now, let's see conceptually how we work. So now, I'm going to redraw the diagram quickly for you. So let's say list currently is pointing to basically A, and also the second one is B. Okay, index 0, index 1. Let's do some little bit transformation. What we want to do is list.add. We want to add to position 1 and this particular element C. Okay, that's what we're going to do. Thinking this way, you're simply just going to insert C into the new index 1. Whatever that used to be an index 1 is going to be shifted to the right. Okay, let's see exactly what we can do. So now, thinking this way, list. So you can think about after the method call, list is just going to point to this following list. Index 0 is still going to be A, is unchanged. But now at index 1 is going to be whatever we want to add it into, right? Index 1. Index 1 is just going to be C over here. What happened to B? B used to be an index 1, as I said, is going to be shifted to the right. Okay? What if you have more than one element that's to the right of the index 1? Shift all of them at one go. Okay? So now after this, we're simply just going to get index 2 and then B. Okay, you can see the pink one is the only thing we changed because we are trying to insert C into index 1. Whereas what used to be at index 1 or after index 1, they are shifted to the right. Any questions until now? Let's verify, yes. Yeah. Yeah.
You specify the index to be 5 in this case, in the case. Would that create an error or would that create randomly generated space?
It's a good question. The question was, yes, let's try. How about this? Let's try together. The question was, I'm going to verify this one specifically and I'll go back to your question. You were asking, what about currently if I say list.add? I simply pass a very large number, for example, 5. You can see 5 somehow conceptually should really be here. So does it really give me any error or simply just going to insert that element? Let's try. Okay, 5 and then let's say D. I'm going to try this in a moment. Okay, let me just do this one first. So I would like to go back to Eclipse over here. Okay. Okay, what I would like to do is let's just go back to the focus over here. Okay, if I say list.add, I want to insert into index 1, and then I want to insert C. I want to show you one more thing. If you're trying to use a debugger to see how things go, it's actually quite nicely supporting Eclipse. I'll show you how to see that. So now what you can do is you can simply just put a breakpoint over here in line number 20. Okay, that's right before I try to do the addition, right before. And then I will run the debugger over here. Okay, I'll just switch to the debugging perspective over here. Okay, I want you to look at, you can see now at the moment I'm pausing at line number 20 right before the execution. You can see under the variables panel over here, there is a variable called list. If I just click on that, you can see it has a very nice view over here. I'll show it to you. The way they visualize it is simply say this. They simply say this simply just corresponds to A and then B. Okay, that's how Eclipse visualize it, which corresponds to how I draw it, the same. Okay, so now if I go back to Eclipse over here, if I try to execute this line, so I'm going to say step over. Okay, if I say step over, you can see now this is the new visualization A, C, and B. Okay, it's after the insertion. If I go back there, so after this, the way Eclipse visualize it is by saying A followed by C and followed by B. Okay, that's the afterwards. Okay, that's about this simple case over here. Any questions? Okay, so now let's have a look at what you were suggesting. What if we give an index that's simply just going out of the bounds? Is it going to create a space, or it's going to give us an error? Either way. Okay, let's have a look. If I just go back to Eclipse over here, let me just stop the debugger. Okay, if I stop it and go back to Java perspective. Now, if I simply do list.add over here, oh, sorry, just add. Okay, if I say list.add, let me just put 5 over here. And then I want to put D. Okay, like that. So now what I will do instead, let's put a breakpoint in line number 21. It's right after I inserted C, so now I got ACB. But before I try to do insert a D, okay? You can see everything compiles. It's a compilable code. If I try to run a debugger over here, let's see. Okay, I'm going to switch to debugger again. Okay, you can see now I'm pausing at line number 21 right before its execution. If I click the mouse to the list, currently simply ACB. Okay, as soon as I say step over, we want to see what happened. Okay, if I say step over right now, it seems to be some exception. Okay, what does that mean? That means every time if you want to insert into the array list, you cannot just give arbitrarily large number. It has to be within the bounds of within the size of the array list. Okay. So now let me just summarize what's going on here. I'm just experimenting to show you. Anything you have doubts, simply give a try on the Eclipse, right? Okay, let me just tell you what happened over here. Over here, for this particular list, we have over here, if you say list.add, I simply say 5, okay? So now this index is not valid. Okay, it's simply just not valid. Okay, so what can you insert into the list? You basically, let's say if currently you got index 0, index 1, and index 2, you can insert at index 0, you can insert at index 1, you can also insert at index 2. Okay, so these are the valid indices you can insert. Okay, any questions? Well, the best way for you to really clarify your thoughts, again, you want to try it out. Okay, I'm just trying to give you a flavor about things work together and how you can debug. Okay, let's now go back to the Eclipse over here. I want to show you something quickly over here. Let me just close this. And that will make notes for you over here. So this will give index exception. Okay, so this is after we have done inserting C. So now let's say we keep that version there. If we got that version over there, so that means we got A, we got C, we got B. Let's do a very quick check, okay? So now if you try that, let me just do one of them to show you. I just want to see what should be index of C after this. And also, what should be the index of B after that, okay? Let me just give you a little bit more help over here. Let me also put index of B, okay? Let me just index of B, okay? And then I'm also going to say the index of B, okay? And then also this should be index of C. So we can really compare the two, okay? And then this one here should also be, let's say, index of C. So we're basically comparing the indices of B and C before and after the insertion. Okay, let's see exactly what's going to happen. Okay, let's see. Let's predict what's going to happen. Before we try to execute this particular method, before that, index of B should be 1. Index of C should be -1 because it doesn't exist. What about after this particular insertion? Index of C should be 1, where it was inserted into. Index of B should be simply shifted to the right, so that should be 2, right? So we're comparing these 4 numbers. Let's now just have a look at the Eclipse to make sure you can verify quickly. Okay, if I try that over here, you can see exactly what we said. Index of B used to be 1, index of C used to be -1 because it did not exist. After we have inserted C into index 1, so now index of C should be 1 and index of B is shifted to the right. Okay, so now it's 2. Okay, any questions? You can see the flexibility of ArrayList makes it a little bit more difficult to trace. So you really want to know how to insert to a particular index. Okay? So now let's do one more. The last method I would like to show you quickly is how you can remove the stuff. Let me highlight this line here in blue. I say list.remove C. Okay? If I do this, what does that really mean? That simply means I simply want to remove an element which doesn't have to be at the end or in the beginning. It could be somewhere in the middle. After I have removed that, what's going to happen? Okay? Let's see exactly what's going to happen. So now, let me draw the diagram again to show you here. Okay, let's say we want to do this particular one. The list is currently pointing to A, C, and B. Okay, A, C, and B. 0, 1, and 2. A, C, and B. And let's do some little bit transformation by calling this particular method, which is going to say list.remove. And then I want to remove C from there. Okay, let's see what's going to happen. Well, naively, you might think I will simply just remove C from here, and then between A and B is simply just null. That's one way of thinking it. But it's actually much better than that. What's going to happen is you are simply just going to take C out and then merge. You're going to collapse A and B together. Okay? Let's verify that, first of all, in Eclipse, and then I'll show you exactly how it works. We want to remove C, right? So now what I will do is I'm going to just do another one here. Okay, let's now do list.remove. Okay, I'll simply remove C. Presumably, according to what I just said, if you're not just going to create a null slot in between A and B, what you want to do is completely remove the slot from B. That's what you want to do. So after this, the size of the list should become 2, from 3 to 2. Again, let me just show you in the debugger quickly. So I will put a breakpoint again in line number 27. Okay? So let's try the debugger quickly. Again, let me switch to the debug perspective. So now we're in line number 27 right before we try to remove. So now if you click on the list in the variables panel, we got A, C, and B. Okay? So now let's see what's going to happen if I say step over. So now we intend to remove the C in the middle. That's what we intend to do. If you simply say step over, now it becomes A and B. Right? You can see C is completely gone. Well, let me draw it right away. So after this, what you will get is you will get still the list, but now it's only just going to point to A and B. Only these two. And then indices 0 and 1. Okay? So now let's go back here to the Eclipse, and then let me stop it over here. And let me just do a little bit more checks for you, and then we are done. So now, what about after removing C? It should be quite obvious. If I say index of C after removing C, it should be -1. Also, let me just do one more. You can also say system.out.println. I can also print out the list directly. Okay? That will actually show you exactly how the list looks like. Let me just try to do the same printout before and after. Okay? That will be the final checks. If I try that again, you can see that before we try to remove the C, it's going to be A, C, and B. After the removal, is going to be AB. What about the index of C in this new list? Well, it doesn't exist, so it's -1. Questions? It's quite a quick walkthrough, but I think that things are quite intuitive. Again, as I said, for ArrayList, it's most important for you to visualize exactly what's going on. It's very flexible in terms of insertion and removal. Oh, good question. If you want to, good question. Let's do an experiment right away. So now let's try this. Let's say currently we have, let's say after removal, at the moment list is simply just pointing to simply just pointing to A and also B. This is what we have. Let's say we want to add to the end of the list. Let's say we want to add D, for example. We want to add to the end. So there are two ways for you to do this, right? Either you can say, I'm going to try. You can definitely say list.add approach 1. You can say list.add, and then I can say D. And this is guaranteed D will be inserted to the end, as we said. What about approach 2? If you want to insert D to the end, it now should be index 2. So it's, I will make a, let me try this first, and then we'll see if that will work. So what I will do is over here, so now we want to insert to the end of the list. So now let me just try that over here. If I say list.add, okay, let's say what index should we pass? Let's say we pass exactly index 2. And by the way, index 2 is exactly the size of the list, right? So what I can do is I can say index, I can simply pass a value over here that's more reusable. List.size. At the moment, size is simply just 2. And then I want to insert D. Okay, so after this, if I try to print out the list, let's see if this might work. If that works, then I'll give you a mini conclusion about how things should be understood. Okay, so that works. So now, what can you do? Right. I'll write it down here. Basically, when you talk about this particular add method in the array list, so you have some integer, index, and also you have some elements. Okay? So now what can the value of this index be? Okay? If you want to insert to the beginning, in that case, you can simply say list.add. And then I'll simply pass 0, and then whatever element it is, right? If you want to insert to the middle, in that case, you can say list.add. And now this can be any value I over here. What can I be? You want to insert to the middle. It would be basically starting from 1 and 2 all the way to list.size -1. Okay, in this case, list.size is simply just 2. If you say 1, that means I want to insert to this particular list and shift it, shift B to the right, right? That's how we did it. Okay, one more. If you want to insert to the end, okay, as we just did, you can say list.add. And then we can simply say list.size. That would be just the invalid index, one off the current largest index. And then whatever it is. Okay, there's a quick summary for you. That's kind of the technical detail you have to be aware of. Okay, it's very consistent with how we think about array. The only thing that's kind of weird is this case over here. You can see if you want to insert to the end, you have to give the size value as the index, which for any primitive array is simply not valid. But in the case of ArrayList, it's flexible. Okay. Now one more thing to say. If you try to say list.add, and then you pass some value I, where I is strictly larger than list.size. Okay, as we just tried previously. So this is going to give you exception about index. That means it's too large. So the largest index you can pass will be exactly the same as the size of the list. Okay? Okay, any questions? So now I think all the cases are presented to you. You should know them both. Should know them all. Okay. Okay, let me just go to a little bit more. Okay, we have done everything we have set up in this particular code fragment here. You can also refer to the slides. Okay. One more thing to say. If you have a look at the code fragment, the last fragment of code over here, we simply try to print out the list. It's very easy. We simply use a normal for loop to say indices should start with 0 until list.size, pretty much the length in the case of the array. And then we can simply try to figure out exactly what each element is in each index. So this is one more method to show you. Given the list, you can simply say get. So it's just another method for you. And now for the get is very basically just identical to the square brackets syntax for array. It's basically the same. Okay, that's how you can print out elements one by one using a for loop. Okay, any question about ArrayList in this example here? Good question. The question was, let me just show you right away. So at the moment, let's see what we got. So now, currently we got A, B, and D. Let me insert B to the end again, so that we got A, B, D, B. Okay? So now let's say list.add, and also add B to the end, which is completely allowed. You can definitely got duplicates in the list. So now, let me just show you something here. If I say system.out.println the list, if I try that, I'm going to see A, B, D, B. Okay? So now let's try this. What would be the index of B? My intuition is it should give you the first index, the index for the first occurrence of B. That's my guess. But let's verify. Okay, so now if I try this, system, you know what? Let me be a little lazy here. I want to know B, right? So now I will simply just copy this line here to help us. What's the index of B? Okay? If you try that, it's simply just going to say 1. 1 corresponds to this particular occurrence of B, so it's going to return the first occurrence. Okay? So now what you should know, again, if you go back to the API over here, there we go. Okay, I'll show you. It's good that you mentioned that. If you look at the API for indexOf, you can see it returns the index of the first occurrence, which means when duplicates exist. Okay, so now you can, I'll come back to you. So let me summarize. If you got A, B, D, B as the array list, index 0, 1, 2, and 3, and then you say index of, let's say B. In this case, it's going to give you the first occurrence. Okay, questions?
What if using that same hypothetical array of A, B, D, B,
Yeah.
you said add, and then called up, say, element 2 there, D, would that add the address of 2 into the short spot? Or does it copy that?
I see what you mean. Let's say this is the list we have. And then you're saying that list.add. And then you want to say add to, let's say, position 2. Like that, right?
Moreover, just list.add in brackets say get list.
Oh, I see what you mean. Okay. Yep, good question. Let me just write it down. It's quite a nice one. I do have space on the top. Okay, I'll write it down. Let's assume we got this particular list. So I would say list dot add. And then add to index 2. And then over here, I'm just going to put another expression here. List dot add. Oh, sorry, get. I want to get index 2, let's say. So what are you thinking?
Yes.
Okay, good.
Minus the initial in that.
Oh, I think 0, 1, 2, 1, that'll be okay. That'll be fine. Okay. So this is going to create an aliasing. Okay. Let me show you. So now before this, okay, so this is what we want to do. Before this, we simply got list is simply, okay, let me just go a little lower. Okay. So we got list over here is pointing to basically A, B, D, B, okay? Okay, 0, 1, 2, and 3. A, D, B, oh, sorry, A, B, D, B, got it wrong. A, B, D, B, okay? Let's say the transformation we like to do is by calling at position 2. And then we're adding exactly the same elements again, right? That's why we say get. Yes, it's going to be aliasing. What's going to happen is, it's going to be something like this. List is just going to point to this particular array. I'll just draw roughly. 0, 1, and 2, and also 3 and 4. Right? That should be the new array list. So now we got A here, and we got B here, and the original D is here, is shifted, and also the original B. So now what about the stuff over here? Right? It's simply just going to be an alias to this particular one. So you can think about conceptually 2 ways to think of it. You can think about it's simply just going to point to this particular slot. Aliasing. Or you can think about it's simply just going to be another D, either way. You just got to be aware that they are referring to the same objects. Okay? Either way. Questions? Is it possible to?
Get a second. The index of, it says you get the first one, right? If you get a second index.
If you want to get a second index of, I'm not really aware of such method. If you really want to get a second index of, you may want to remove the first one and then get a second one. Yeah, not that I'm aware of. Yeah. The question was, the index of is simply just going to return the index of the first occurrence. Is it possible to return maybe the second occurrence? I'm not really aware of such method. There could be. Yeah. I'll look it up. If I find it, I'll let you know. Okay. Any other questions? Okay, we got about 5 or 7 minutes. I would like to give you a very quick conceptual picture about Hashtable quickly, okay? And then we can continue the rest on Wednesday. One more thing to say. If you go to the slides for classes and objects, so you can just go to 3.3.1. I'll just go there quickly. Okay, if you go there, we basically, for that one, I would expect you to study by yourself over there. Okay, I'll just go there quickly. So it's a 3.3.1 Java data types. So 3.3.1. Okay, I tell you what this slide is about. Basically, in the previous slides, we basically talk about how you can use the primitive array of points, right? That's what we talk about. And then we talk about how you can define this particular accessor method called getPoints in the first quotient. So now, 3.3.1, which I refer you to, is something we simply say rather than using a primitive array, we simply use an array list by using all the add and by using all the add and get method that we just talked about. Okay, So now you can see in line number 2, rather than declaring an array of points, we simply say array list of points over here. Okay, that's the change. And then the return value over here, array list of points, rather than a primitive array of points. And then we simply show you inside the method how we can create a new array and then do the rest. This will be useful for you to complete your lab number 7. Okay? So that one should be quite straightforward. I'll leave you to study for that. Okay? Of course, that will be covered in the exam. So you better go over that. If you got trouble, drop by my office hour to ask me questions. Okay. Let's go to Hashtable quickly. Let's think about how you can think about the Hashtable. Of course, again, if you there's a link in the slides. If you go to the link, you will see the class called Hashtable. The complication about Hashtable is like this. You got a concept called key. You got another concept called value, which I'm going to explain. Okay? And then if you go to the Hashtable, you can definitely read through it over here. Okay, so they got some implement a Hashtable which maps key to values. So these are the two concepts. One is called keys, the other one is called values. Okay? And also, I also gave you some methods that you should know about in the method summary. Okay? You can go through the web page. Let me just go back to the iPad. This is the minimum API you should know about the Hashtable. So what do we have? We have size to see how many things you store in the Hashtable. We also got whether the key is contained or not, and whether the value is contained or not. And also we can get something. So rather than passing the index, like in the case of the array list, we pass a key. And also we can try to insert something into the Hashtable. The way you insert into the array list is by inserting a single element. But now in the case of the Hashtable, you have to insert a pair, key and value. And also you can remove something. Let me give you a quick conceptual model about Hashtable. And then we'll finish the code on Wednesday. So what's really a Hashtable? Okay. So now this is how you can think of it conceptually. You can think about it simply like a two-dimensional table that you can create easily in Excel. Okay, and then we have, let me show you this. It basically is a table with two columns. And we have the keys, and we have the values. Okay, two columns. So two concepts for you to know about, keys and values. Let's take one example over here. Let's say we want to have a Hashtable. We want to have a table between students' name and their letter grades. Okay? For example, we might say Alan, the name of the students, he has got, let's say, A+. Okay? So what we are talking about is, let's say, keys. In this, for example, it can be the names of students. And as for the values, let's say it's the letter grades. And then I'll talk about some very important properties in just a moment. Let's say for Alan, he simply got A+. Okay, let's say we got also Mark. And also we have Tom. Let's say we got 3 different entries. And then let's say Mark simply got, let's say C, and Tom also got A+. Okay, it's just a table. Okay, this is how you can think of it. Hashtable simply got a collection of entries. Each entry simply contains 2 things, the key and the value. Okay, the key and the value. So here, Alan, Mark, and Tom, they are all the keys. Alan, Mark, and Tom, they are the keys. On the other hand, A+, C, and A+, so these are the values for the table. Okay? So now there's one very important property for you to understand. Think about realistically. If we have, let's say for 1021, every student has their unique name so that we can identify their corresponding entry in the table. Okay? So now let me put it here. Keys contain no duplicates. You can see we got Alan, we got Mark, we got Tom. No duplicates. On the other hand, the values over here, the values may contain duplicates. For example, you can see A plus and A plus over here, right? Okay. So that's about the concept for a table. Any question about this conceptualization here? Okay. So hash table will be very important for you to use in order to complete lab number 7. Okay. I think I will stop over here, and then on Wednesday I'm going to continue from this and then finish the code. And then I'll talk about the exam on Wednesday.